To begin with our similar figures test review, we first need to talk about mid-segments and medians. When we're discussing the formula for mid-segments, we always talk about the triangles having two different formulas. If we are given this bottom length, and we'll call it A, and we need to find out the length of x, the formula for that would be A is equal to 1/2 or 2 times x. Meaning that if I want to go from my small segment to the large one, I need to double the length of my small segment to get the big value. So if I wanted the reverse to happen and find out what x equals, that means I have to take half of the value A. These are my two formulas when we're working with triangles with mid-segments. So take a look at number 1. In number 1, we're given the large value of 18, and we're told to find the length of kj. Remember, if we have to find the small length, we have to have our largest value. So that means to get the length of kj, we need to take half of the full length of AC. And in this case, we're told that AC measures to 18. So kj is equal to 1/2 times 18. And 18 divided by 2 gives us exactly 9. That would be our value. And the same goes if we have to go in the opposite direction. In number 2, we're told that VU measures to 9, and we have to find the length of DF. So we're going to be using our first equation from over here, which means that DF is equal to 2 times the length of VU. And we're given that VU is equal to 9. Substituting in what we know, then that means that DF is equal to 2 times 9, which is just equal to 18. And that would be our length of DF. Medians are a little bit more tricky. When we're talking about medians, we look at it in two different parts. We go from the vertex to the centroid, which is the center of your triangle, all the way to the midpoint. We have 3 different points right here that's accounted for in our median, which means that if I need to find the equal parts length here, I need to take the full length of M, C, and V and divide it into 3 equal parts, which means that whatever MC is equal to, that means that C to the midpoint between these 2 points is equal to the midpoint to V. Each equal part would be the same value, which means that if I'm given the full length of a median, to get 1/3 of it, you divide it into 3 equal parts. There's 2 equations that are associated with medians. Your first part is that the length from the median to the centroid is equal to 1/3 the length from median to vertex, as well as the length from centroid to vertex is equal to 2/3 from the median point to the vertex. Let's keep these 2 equations in mind while we try to solve number 3. So for number 3, we're told that in triangle LMN, point P right here is our centroid, and that from B to P, the measurement is 3. Now we have to find the full length of LB. Now, since we're given the 1/3 length, that means we're going to be looking at this equation right here, our first one. So we'll plug in what we know. We know that BP is equal to 1/3 the length of LB. We know that BP is equal to 3, so 3 is equal to 1/3 of LB. Now, when we're multiplying a fraction to a variable like this, we have to multiply by the reciprocal, meaning that we're multiplying both sides by the flip of the fraction. So if this is 1/3, that means we have to multiply the right side and the left side by 3/1. 1/3 multiplied by 3/1 gets rid of them. But on the left side, even though this is 3/1, we're going to multiply straight across as if we're multiplying 3 times 3, which means 3 times 3 gets us 9. And 9 is equal to the full length of LB. Now for number 4. In number 4, we're told that in triangle LMN, point P is still our centroid, but that PN is equal to 12. We have to find the full length of AN. We're told the 2/3 length, so we're going to have to use the second equation that we wrote. Write in what you know, that PN is equal to 2/3 the length of AN. And we're told that PN is 12, so 12 is equal to 2/3 of the measurement AN. Just like in number 3, I'm going to have to multiply by the reciprocal. Since this fraction is written as 2/3, that means my reciprocal is 3/2. Again, when we're talking about reciprocal, we're talking about the flip of the fraction. So multiply both sides by 3/2. Now, 2/3 multiplied by 3/2 gets rid of it. But since I don't have a 1 underneath, I'm going to multiply straight across, which means I'm multiplying 3 times 12, and I'm multiplying 2 times 1. And all that is equal to AN. Let's go ahead and solve out the algebra for the numerator and the denominator. 3 times 12 gets us 36, and 2 times 1 gets us 2. So we're left with the division problem to find the full length of AN. Well, if we divide 36 by 2, we get the total length that AN is equal to 18. Let's go ahead and give mid-segments a try when there's algebra involved. Solve number 5 on your own. I'm going to go ahead and solve number 6. So for number 6, we're going to be looking at the mid-segments here. Now again, if I want to get the length of the small one, we can use either equation that we found above. We can use either our big is equal to 2 times the small, or we can use that the small is equal to half of my big. To keep things simple, I'm going to be sticking with this first one up here, that the big is equal to 2 times the small. So below here, that means that CA is equal to 2 times IH, because again, CA is considered my big base, and IH is considered my smaller mid-segment. Let's substitute in these equations, x plus 24 and 30 plus 2x. X plus 24 is equal to 2 times 30 plus 2x. Now for this problem, we started working with algebra, where we have to distribute first before we can start solving for x, which means we have to do 2 times 30 and 2 times 2x. Keep your left side the same. We're going to still write x plus 24, but on the right side, we're going to multiply 2 times 30 to get 60 as our constant, and we're going to multiply 2 times 2x to get 4x as our variable. Now we have to start solving for x. The trick when you're working with these is I like to start with our x's first. When you're subtracting and you have 2 x's on both sides, look for the one with the biggest value. And in this case, my biggest value is 4x on the right. That means we're going to subtract x from the left and x from the right. This allows us to keep a positive number in front of our variable. Your equation, when you do this operation, should now look like 24 is equal to 60 plus 3x. Now you get rid of your constant. We cannot have constants on both sides of the equation, so what you need to do is subtract 60 from the right and the left side. So minus 60 on the right, minus 60 on the left, and here you should be getting a negative value. So what you can do is subtract 24 minus 60, and you should get a value of about negative 36, and set it equal to 3x. The last step here is to get rid of this multiplied 3 that we have in our variable. So divide both sides by 3, and your value of x will end up equaling negative 12. It's a little bit more work, so be sure to write down all of your steps as you go through it so you can see your algebraic mistakes. You can catch yourself when everything is written out. If you don't have everything written out and you rely solely on your calculator or mental math, it's very easy to mix some of this up. Let's go ahead and move on to number 7 and number 8. Here we're comparing similar figures. Here we have a shape A, B, C, and D, and a shape Q, R, S, T. When you're given shapes like these and you're not told where we're dilating from, assume that we're dilating from the left to the right. Part A is asking us what the scale factor is. Now the scale factor is a formula where you divide your new measurements divided by your old. New measurement divided by the old. Which means in this case, we have to still keep it proportional. So if I'm looking at AD, with AD being my old, then QT is my new measurement. Your K is equal to the new measurement of QT all over AD. And if I substitute in the values that I know, that means the ratio should look like 5 over 10. And I can simplify this. 5 over 10 can be simplified to a 1/2 as my scale factor answer. Part B is asking us what angles are congruent. And when your angles are congruent, it's congruent in the same part of the shape, which means that angle Q is congruent to the angle in the same part of the shape in the original one. Q is proportional to angle A. Again, seeing as they're both in the same position and that AD is similar or proportional to QT, that means that angle Q must be congruent to angle A. Part C is discussing proportions. It's comparing QR, the top side of the shape for the new shape, to the old top side, AB. This is equal to RS, the right side of the shape, but we don't know the bottom. Well, since we did top to top, that means we have to do right to right. And since we're starting with RS as our right side, then it must be over the right side BC. Again, we're setting up our ratio as top over top is equal to right over right. We're setting our scale factors equal to each other because, again, what we're doing is we're having the new measurement of the top divided by the old measurement of the top. So if I wanted to look at the right side, we need to take our new measurement of the right and divide it by the old measurement of the right to keep that same proportionality. Now let's solve for x. Well, again, we're talking about scale factors. So we already know that my scale factor for QR divided by AB is actually 1/2. And I'm told that RS is 4, but I do not know the measurement for BC, which is x. The way you solve these is you do cross multiplication. Cross multiplication means you're going to be multiplying the top left of your proportion to the bottom right, and you'll be multiplying the bottom left proportion to the top right. So that means we have 1 times x to get us x on the left, and 2 times 4 to get us 8 on the right. So your missing measurement is x is equal to 8. Let's do this again for number 8. Just like in 7, when you're not told where we're dilating from, assume we're doing left to right. So even though my small triangle is on the bottom, I'm still going to assume that I'm going from HGM to KHL. Which means that if I'm going to do part A and find what my scale factor is, I'm going to do HK is proportional to HG, with HG being my old and KH being my new. Plugging that into my equation with KH as my new and HG as my old, I have 15 over 10. I can simplify both the top and the bottom of this fraction by 5 through division. If I divide both the top and the bottom by 5, your new scale factor should equal 3 over 2. Now again, we have similar figures here, so if you have similar figures, that means that congruency and angles exist. And since they're in the same position, I can look for what's proportional to each other based on their positioning. So if angle M has a congruent angle, L must be its partner. Angle M is congruent to angle L. Moving on to part C. Part C is saying that HM is proportional to KL. HM is proportional to KL. And we don't know the top, but we know that our bottom measurement is HK. This is kind of a flip of what we just did, with the big being our new, or with the small being our new, and the big being our old. So originally we said that KH was our new, and that HG was our old. If we flip that to say big is new, small is old, we just have to flip our fraction from part A, which means your missing part of this proportion is just HG. And now we just solve for x. Well, we know our scale factor is just a flip. which means that since part A was 3 over 2, that means your scale factor is 2/3. Now 2/3 is equal to HM of 12 all over your missing value of x. Like in part D, we're just going to go ahead and cross multiply. So 3 times 12 and 2 times x. 2 times x gives you 2x, and 3 times 12 gets you 36. Now, if you have anything multiplied to your variable, you need to divide it away, which means we have 36 divided by 2 to get us a value of x is equal to 18. Next, for these notes, you will complete number 9 and number 10 on your own. Remember that you're going to be moving from left to right. Left to right. So for number 12, again, we know that this follows the same 2/3 rule as our medians. So that means RT is equal to 1/3 PT. So RT is equal to 2x minus 2, which is equal to 1/3 of 12 plus 2x minus 2. If we add these together, you get 2x minus 2 is equal to 1/3 times 2x plus 10. The easiest thing to do is to get rid of this fraction right here. So multiply both sides by the reciprocal of 3 over 1 on the left and 3 over 1 on the right. And since we're multiplying 3 over 1 to an expression, we're going to need to distribute it, which means you have 3 times 2x to get 6x minus 3 times 2, which is just 6, and that is still equal to 2x plus 10. Now we solve for x. First thing to do is to subtract your 2x on the right side and the left side. And once you subtract, you should get 4x minus 6 is equal to 10. Add 6 to both sides to get the equation 4x is equal to 16, and now we have a simple division problem. 4x divided by 4 on the left and 16 divided by 4 on the right gives you an answer of x is equal to 4 for number 12. Now for number 13, we have a proof. And this proof will be seen on your test. We have to work with what's given to us first. And we're given that TU is parallel to QS. Set up your T-chart. I'm going to start on the left side and work my way to the right, since I tend to write these things a little bit bigger than I should. We start with our statements and our reasons. And your first thing to always start with are your givens, which is that TU is parallel to QS. Next, we need to think about what this means. Well, if TU is parallel to QS, that means we have angle relationships here because we have a set of parallel lines with traversals going across. Here is your set of parallel lines, and we can consider the sides of your triangle to be the transversals. So this means that RTU has to be congruent to ROS by corresponding angles. And the same thing also occurs when we look at RUT, and that also has a corresponding pair to RSO by corresponding angles as well. So for your third statement, write down that angle RUT is congruent to angle RSO, as well as angle RTU is congruent to angle ROS by corresponding . This is important right here because this is how we declare similarity. What we've just proven is we've proven what's called the angle-angle similarity. Angle-angle. And when you have angle-angle similarity, that means in two different triangles, you have two different congruency pairs. So declare that triangle RTU is similar to triangle ROS by angle-angle theorem. Now that we've proven similarity, we need to take a look at the proportions in these triangles. So I'm going to redraw my statements and reasons chart to the right to give myself a little bit more room. And I'm going to take a look at the proportions. Well, I can see that we need to keep it on the same side. So our given statement is that TR is going to be proportional. So I will rewrite this as QR is over TR, or proportional to TR. And that proportion is equal to SR, which is proportional to UR. And this is quite the reason for it. It's a little bit lengthy, and I'll write it down in full. This is due to the corresponding side lengths of similar figures are proportional . Now we need to take a look at what makes up these sides. I can see that for the bigger triangle right here, that QR is equal to the addition of segment RT plus TQ. Same thing goes for the other side. I can say that RS is equal to the addition of segments RU and US. This is called the segment addition postulate. now that we've discovered what QR and RS exactly equal, we can take these two equations and substitute it back into our proportions that we've created, which means that I'm going to substitute in RT plus TQ on the left, and I'm going to substitute in RU plus US on the right. So your next statement should be RT plus TQ divided by TR is equal to RU plus US divided by SR. And we're using substitution for this. Next up, we can't exactly solve it the way it's written, so we're going to have to do a rewrite. And your rewrite statement should be TR, I'm going to rewrite this part right here as TR, divided by TR plus TQ divided by TR is equal to RU divided by SR plus got these two mixed up right here. Found the mistake. The bottom right here should be UR, and the bottom right here should be UR. Plus US divided by UR. The importance of fixing that mistake right here is because through this rewrite, I can actually get rid of two of these proportions. We're going to do simplification. So your next statement for simplifying should be getting rid of TR and UR, so it should be just 1 plus TQ all over TR, which is equal to 1 plus US plus UR. We've almost proven the statement from above. Now the last thing you have to do here is to get rid of these ones. And the only way we can get rid of these ones in this equation is through subtraction. And once you subtract, you'll get your proof statement of QT divided by TR is equal to SU over UR. And that is how you do number 13. For the next page, I'm going to have you do number 14 on your own. I'm going to go ahead and do number 15 and number 16. So in number 15, we're told that the length of two sides of triangles are in ratio of 6 and 7, which means your new measurement is 6, and your old measurement is 7. And the area of the larger triangle is 45 centimeters squared. We have a big triangle here, and we have a small triangle with its scale factor of 6 over 7. Now, the area of the larger triangle is 45 centimeters squared. 45 centimeters squared. And we need to find the area of the smallest triangle to the nearest tenth. The way you set up your formula for these problems is you have to do it through the proportion. Now again, your scale factor is telling you you're going from the big triangle to the small triangle. So for your areas, you're going to write it as the mystery area of X all over 45 centimeters squared. And this is equal to your scale factor of 6 over 7. Now the problem is that when we're working with area proportions, we need to match the units in a way. Notice here that your units are squared. Since my units are squared for area, that means that your scale factor must also be squared. Make a note to yourself on the side about scale factors in word problems. For perimeter, your scale factor stays the same. For area, you have to square your scale factor. For volume, you must cube that scale factor. So let's distribute our square to the top and the bottom. Your ratio should still be x over 45 on the left, but on the right, you'll have 6 squared over 7 squared. And when you plug both of these into the calculator, your ratio ends up looking like x over 45 is equal to 36 over 49. Because again, when you are squaring a number, what you're saying is that you're multiplying 6 by itself twice. So 6 times 6 for the top and 7 times 7 for the bottom. Now we're going to do cross multiplication, which means we have 45 times 36 and x times 49. Rewrite your equation below as 49 times x, which is equal to 36 times 45. When you multiply the right side out, you will have 36 times 45, which is equal to 1620, or 1,620. Now, since we only have a number being multiplied to my x, I have to now divide both sides by 49. Well, I know 49 divided by 49 just leaves me with my variable x on the left, but if I divide 1,620 by 49, you get a decimal of about 33.061. In the instructions, they tell you that if you get a decimal, you have to round to the nearest tenth. And the tenth spot is the first number to the right of your decimal. Since it's next to a 6, I can round this number to be x is equal to 33.1 centimeters squared. That would be my answer. Now for 16, I will start the problem and draw out what you should have. You will finish number 16 on your own. In this problem, you're told that the ratio of the two sides is 5 to 7, which means that your scale factor is equal to 5 over 7, with 5 being your new and 7 being your old. Which means that we have a big cube and we have a small cube. Notice I'm taking the time to draw this every time. These problems are a lot more difficult to visualize in your head, so make sure that you are drawing everything that you have for these word problems. We're told that the volume of the larger cube is unknown. So we don't know the volume of the large cube, but we do know that the small cube has a volume of about 486 meters squared. 486 meters cubed. I apologize. It's actually cubed. We need to round this to the nearest tenth. We're going to set it up in a similar way that we did above. We're still going small over big, which means that for your volume, you need to write 486 meters cubed all over x, because we don't know our original volume. which is equal to your scale factor of 5 over 7. But as mentioned above in the notes, when we're working with volume and scale factor, we need to cube it. So rewrite your equation below. You should have 486 over x is equal to 5 cubed over 7 cubed. 5 cubed is about 125. So 486 over x is equal to 125. And then 7 cubed is equal to 343. The next step is simply to just cross multiply. So once you cross multiply, you should have an equation that looks like this. It's going to be rather large. You're going to have 343 times 486, which is equal to 125 times x. Your first step is to multiply 343 by 486 to get a very large number of about 1,698. That is all equal to 125x. From here, finish the problem on your own. Let's move on to 17. I will show you how to do 17. You will need to complete 18 on your own. So for 17, we need to solve for this missing value of x. Well, when we're given 3 right triangles like these, we need to break these apart in right triangle problems. We technically have this really big one right here. We're told in this big one that's pre-drawn for us that the hypotenuse is 12 and that the height is 6. But there are 2 more triangles in here. There's what I call the second largest triangle, and we have the third largest triangle, or our smallest one. So if we draw out both of those triangles right here, we can start assigning measurements. Now, for the second largest, or my purple one, I actually have no measurements to assign to it. I don't know its hypotenuse, I don't know its height, nor do I know its base. But I do know measurements about my smallest. It may be a little hard to see at this angle, but if I rotate my paper towards me, I can see that my height for the smallest triangle is x. I can see that I don't have a measurement for my base, but I do have a measurement for my hypotenuse, which is 6. So with this information, I'll go back to my drawing that I did on the left, and I'm going to label everything I know about the smallest triangle. That its height is x, its hypotenuse is 6, and that I don't know anything about the base. With all this information filled out, I could start pairing up different information about the proportions. I can claim that my heights are proportional to each other in this problem, which means that if heights are proportional, that x is proportional to 6. And if heights are proportional, then hypotenuses must be as well. Once you find every measurement that is proportional to each other, then you start pairing it up in an equation. I'm going to put my biggest value over my smallest. Starting with the hypotenuse, that means I should have 12 over 6 is equal to my heights, which is 6 over x. Before I start, I can actually divide or simplify my left side first. This ratio of 12 over 6 can be simplified by dividing 6 on the top and the bottom. So your new equation, once simplified, should look like 2 over 1 is equal to 6 over x. Now that it's simplified, you can go ahead and cross multiply. And when you cross multiply, you should have an equation of 2x is equal to 6. Since I'm still multiplying a 2 to my x, I need to divide both sides by 2, which means that your missing value of x is equal to 3. Again, take your time and solve number 18 on your own. For the final page, there are 2 word problems. You're going to go ahead and do number 19 on your own, and I'll show you how to do 20. Like I said with the other word problems, drawing is key here. So for number 20, I have a Ferris wheel. I'm going to draw a little Ferris wheel right here. Geometry can be art class when we really want it to be. And on this Ferris wheel, it casts a 20-meter shadow. So I'm going to say starting from here, it's casting a 20-meter shadow. Now, I also have this man standing near it. And the man is actually about 1.8 meters tall. So his height is about 1.8 meters. And his shadow is about 2.4. So his height is about 1.8 meters, and his shadow is about 2.4. We need to use this information to find the unknown height of my Ferris wheel, because we don't know the height for the Ferris wheel. But the reason why I take the time to draw these is it illustrates the fact that we actually have 2 similar triangles here in this word problem. Like before, when I was working with the right triangles, where I drew all 3, I'm going to be pairing up based on the positioning of these measurements, which means that I want to pair up my height with my height, and I want to pair up my shadows with my shadows. So I'm going to write it as this. Let's do our x's on top, which means we're going to put our big values on top. We're going to do big values on top with the small on the bottom. So for the shadows, that means we have to do x over 1.8 meters. And that's equal to the proportion of the shadow for the Ferris wheel, which is 20 meters, all over 2.4 meters. Next up, we go ahead and we cross multiply. X times 2.4 and 1.8 times 20. So on the right side of your equation, you should have 2.4 meters times x is equal to 20 times 1.8 meters to get you about 36 meters squared. I'm squaring because I'm multiplying 2 of my meters measurements twice together. Now we need to get rid of this 2.4 meters being multiplied to my variable. Divide both sides by 2.4 meters, and we can say that 36 divided by 2.4 gets you a value of about 15. So your value of the height should be 15 meters. Again, when you're doing these problems, draw them out. Do not pretend to know what they are in your head. You can easily see this triangle relationship when you have it on paper. Finally, we're going to look at our similarity theorems. Starting with 20. In 20, I'm told that angle C is congruent to angle D, but nothing else. However, I can assume that since we have two angles across from each other, sharing a vertex like this, that angle QBC is congruent to angle NBD. So angle NBD is congruent to angle QBC, as well as angle C is congruent to angle D. Since I have two sets of congruent angles in these triangles, I can declare that they are similar by angle. Next, I'll go ahead and do number 22. I don't have any angular relationship here, but I can check for proportions by side angle side and side side side. So I can't do angle angle, but I can check for side angle side and side side side. Now since I still don't have any angle relationship here, that means it also eliminates side angle side, which leaves me with just the theorem of side 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 to work with. But since I don't know the measurement of PC or GZ, both these sides are blank, I can't claim side 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 similarity as well. If you're not given information on all three sides for each triangle, you cannot claim this to be a theorem. So since all three theorems fail, 22 has an answer of not similar. Go ahead and try 23 and 24 on your own. When you're done, go ahead and submit this and finish your practice test as well.